Hey there, and welcome. Today, we're going to dive into this amazing, invisible world that takes simple ingredients and transforms them into something totally new and, yeah, usually pretty delicious.
I mean, really think about that for a second. You mix everything up, you stick it in the oven, and boom, a perfect cake comes out. But could you ever go backwards? Could you actually pull that flour and those eggs and that sugar back out of the finished cake?
Well, the short answer is absolutely not. No way. And the reason why is the real star of our show today.
That's the secret right there. The moment you bake that cake, those ingredients are gone for good. Now, they haven't just vanished into thin air. Oh no. They have been permanently changed by something we call a chemical reaction.
Okay, so let's get right into it. What exactly is a chemical reaction when we talk about it like this?
So here's the key idea. Nothing is actually being created or destroyed here. Just think of atoms as being like Lego bricks. A reaction just takes your original creations apart, the flour, the sugar, and it rebuilds all those same bricks into something brand new. In this case, a delicious cake molecule.
Now, the cool thing is that these reactions are happening around us all the time. But how can we be sure? How can we be chemical detectives and find the proof?
Well, you're going to want to look for these three main clues. Are you seeing bubbles where there weren't any before? Is there a color change that you know isn't just from mixing two colors together? Or maybe there's a really big temperature shift, something gets super hot or icy cold all of a sudden. Those are your telltale signs. But wait a minute. This is where it gets a little tricky. I mean, you see bubbles when you boil a kettle of water, right? So is that a chemical reaction? Let's take a closer look.
Okay, this slide just nails the difference. Over on the left, when you mix vinegar and baking soda, you're creating a totally new thing, carbon dioxide gas. You can't turn it back. But on the right, boiling water just turns liquid water into steam. It's still just water, and you can easily cool that steam and turn it right back into liquid. So that's the key, a permanent chemical change versus a totally reversible physical change.
And the exact same rule applies to color. When you cook an egg, that clear liquid permanently becomes a new, solid white substance. That's a chemical change. But making a cup of tea? Well, that's just a physical change. You're not making anything new, you're just mixing tea particles into the water. See the difference?
All right, so let's zoom out a bit and see how this all connects to the world around us. Because these reactions, they aren't just for science labs. They are happening everywhere, every single day.
I mean, just take the kitchen. Chefs are basically masters of chemical reactions, even if they sometimes call it magic. Let's look at how they whip up a classic treat like honeycomb.
That's the secret. The bicarb reacts with that hot sugar, and it produces tons and tons of tiny carbon dioxide bubbles. Those little bubbles get trapped as the sugar cools and hardens, giving the honeycomb that amazing, light, airy, crunchy texture we all love. It's chemistry you can actually eat.
And seriously, this goes way beyond the kitchen. The energy that heats our homes and powers our cars, that comes from chemical reactions. The plastics in pretty much everything we own, the medicines that keep us healthy, all of it is thanks to our ability to control and use chemical reactions.
Okay, want to see a reaction up close? Here's a super simple one you can try at home, with an adult helping, of course. First, just mix some vinegar and baking soda. You'll see it fizz and foam like crazy. That's the reaction creating carbon dioxide gas. Now here's the really cool part. CO2 is heavier than air, so you can actually pour the invisible gas out of the glass and onto a candle flame, and it'll put it out. It's like pouring invisible water. It's an amazing little trick.
To really truly understand what's happening here, we need to zoom in. I'm talking way, way in. We need to look at the story from the point of view of the atoms themselves.
And this brings us to one of the most fundamental rules of the entire universe, sometimes called the law of conservation of mass. It basically means that in any chemical reaction, atoms don't just appear or disappear. They are simply rearranged into new patterns.
Just look at this example of making iron sulfide. Before the reaction, we start with a set number of iron atoms and sulfur atoms, 16 in total. Now look at the after column. We still have exactly 16 atoms. They've just hooked up in a new way to form a totally new substance. In chemistry, the books always have to balance.
So what percentage of atoms are actually conserved in a chemical reaction? Well, this slide says it all, 100%. Every single atom you start with is still there at the end. No exceptions. It's a fundamental rule.
And that brings us right back to our cake. The reason you can't unbake it, the reason you can't get your eggs and flour back, is because their atoms have been completely rebuilt. They've formed new partnerships to create all the new substances that give a cake its wonderful texture, its flavor, and its amazing smell.
So I'll leave you with this final thought. Right now, wherever you are, there are countless chemical reactions happening all around you, from the battery powering your device to the simple act of you breathing in and out. What other ones can you spot in your world? Thanks for joining me.